I think it's that time
All right.
for the first of our student presentations. Dr. Schnell?
Can you hear me from anywhere over here?
Sounds like it.
Yeah.
Okay.
Yeah, really.
All right. So it's my pleasure to introduce Jack Nielsen, and he is from Johnston, Iowa. Let me see. BS in biochemistry from Iowa State in 2015. Then he went down to the University of Florida, completed a master's degree in agronomy, finished that in 2018. And from there, he moved over here to the Soil and Crop Science Department at Texas A&M and started his Ph.D. program with us in June of 2018. So today he's going to talk about his project, looking at cover crops in corn and sorghum here in Texas. So, Jack.
All right. Thank you, Dr. Schnell, for that introduction. As he said, for those of you I haven't had the pleasure of meeting, my name is Jack Nielsen, and I'm here today to talk to you a little bit about my research project, which is examining the effects of different fall cover crops in corn and sorghum systems here in Texas. So before I get going, before I get in too deep, what do I mean when I say cover crop? What is a cover crop? So a cover crop is a crop that is grown not for food, fuel, or fiber, but one that is planted predominantly in order to provide ground cover, which makes sense. It's a cover crop. There's not, say, like a set list of cover crop species. Cover crop can be anything. It's more how you use it. So there are summer and winter cover crops that have been successfully incorporated into a variety of agricultural systems all over the world. And these are done for a variety of reasons. Kind of chief among them and reasons for cover crop adoption would be to prevent erosion. So cover crops, they shield the soil from wind and from rain. And they having kind of a living vegetation in the field can also slow down running water that might exist due to a heavy rain event or, say, snow melt. That increases some of that resistance and slows that water flow down, reducing erosion. Cover crops can also scavenge nutrients that might be left over in the field following cash crop harvest, particularly nitrate, which is, of course, of special interest due to its negative environmental effects if it, say, gets into surface water. However, cover crops can also be used to provide nitrogen via biological nitrogen fixation, or, say, a legume to be used as a cover crop. Cover crops, also can be used to help with soil health. They reduce soil compaction, improve your soil organic matter, and there's some interest in using cover crops for kind of carbon sequestration, carbon credits, and the like. Last but not least, cover crops also may provide a benefit for weed control. So all that sounds great, right? But there's as we know, there's no such thing as a free lunch, and there are associated costs with cover crop adoption. Of course, you're paying for seed. You're going to be paying for labor. You're going to be using diesel to put those cover crops out, not to mention the hours you're going to be putting on your equipment. And that's if you have the equipment to plant and manage those cover crops in the first place. Besides that, there's also that cover crop is going to be using water, and in some systems where there's not a lot of rainfall, where the crop relies predominantly on stored soil moisture, cover crops might have a negative effect there as well. But we'll go ahead and move on into the kind of the rationale behind this study. So as we know, herbicides, they're a primary tool for weed management, but due to an increasing number of herbicide-resistant species, as well as herbicide-resistant biotypes, there is increased interest and demand for non-chemical methods of weed management. Cover crops, they could be a tool kind of in your tool belt in weed management. They're not going to do everything, but they can help, and they may influence weed populations by either competing directly with the weed species themselves, competing with them for space, water, nutrients, things of that nature, or their residues after the cover crop has been either physically or chemically terminated, and that's if you leave it on the surface and don't incorporate it, may form a physical barrier that impedes weed seed germination and weed seedling development. So while, as I mentioned, there are possible benefits, we also wanted to evaluate any possible negative effects as well on cash crop grain yield, as well as on cash crop stand and establishment. So our objectives that I'll be focusing on for this presentation were three. We wanted to determine which cover crop species or mix of species incorporate well into our corn and sorghum systems, determine the effects that these cover crops have on weed control, and to examine any impacts these cover crops may have on subsequent cash crop yields, as well as on cash crop stand. So I'm sure this field site looks familiar to just about everybody in this room and most of the folks on the Zoom as well. This was a 2-hectare field experiment that was performed at the Texas A&M AgriLife Research Farm, the Brazos Bottom, just down the road. This image here, I guess I can use my cursor. This is an aerial photograph that I found on the Texas Natural Resource Information Services website. It's a handy little resource if you're looking for aerial photography and don't have a drone. And it shows how my cover crops were set up in the field. And this image was taken late January of 2019. So the cover crops are well established, and kind of the stripes where you don't see anything, those are my fallow treatments, which I will be explaining shortly. According to the new NOAA climate normals that were released earlier this year for 1990 to 2020, the field site receives an average annual precipitation of 106 centimeters, which I believe up from 99 centimeters according to the last climate normals. And the average annual temperature is 20.8 degrees Celsius. The soil series where my plots are, it's the Westwood series, it's a silty clay loam. And the experiment was performed from October of 2018. And we just got our last samples out of the field last month, so September of 2021. So this was a split plot design with 3 replications, 2 cash crops, which were treated as independent experimental units, which were, as I mentioned at the beginning of the presentation, grain sorghum and corn. The grain sorghum was planted at a rate of 160,000 seeds per hectare, and corn was planted at a rate of 69,000 seeds per hectare. The main plots were defined by their herbicide treatment, which I will be explaining in the next slide. And the split plots were defined by their cover crop, and we had 5 levels, which I will be explaining shortly as well. So as I said, we had 4 herbicide treatments. These 4 main plots, they all received a pre-emergent application of S-metolachlor and atrazine. And for one of those treatments, that's the only herbicide it received. One of those main plots, I should say, rather. For the other 3 main plots, they also received an additional post-emergent application of S-metolachlor and atrazine at that same rate, and the timing of which define the treatments. We had 3 of them, which are kind of shown at the bottom of this slide here. So on average, a post was applied 23 days after planting, 38 days after planting, and 47 days after planting. Within that pre-emergent only plot, in the 2nd and 3rd year of the study, we also incorporated, we've been calling it kind of a micro plot, which received no herbicide treatment at all. And that kind of acted as a true weed check against which we evaluated percent control of weeds. And that brings me into my cover crops, which define our split plots. So we had, of course, a fallow treatment. Now fallow, as one would expect, didn't have a cover crop on it, but no cover crop did not necessarily mean the plots were vegetation free. So these images were taken February 27th of 2020. And you can see that, by late February, most of the henbit that we'd see is kind of gone to seed and died out. But there is still, some shepherd's purse and kind of a smattering of other things in there as well. The first cover crop that I'll mention here is, it's a hard red spring wheat, which is planted at a rate of 112 kilograms per hectare. And you can see by late February, it started to head out and kind of enter the reproductive stages of its development, which we saw every year. Our next cover crop was a soft red winter wheat, which was again planted at a rate of 112 kilograms per hectare. We had a 5-species mix, and this was planted at a rate of 56 kilograms per hectare in order to keep cover crop seed costs comparable to the other treatments. So in this mixture, it contained by weight of seed, 25% triticale, 25% oat, 20% Austrian winter pea, 15% crimson clover, and 15% hairy vetch. And last but not least, we had our cereal rye and hairy vetch mixture, which was planted at a rate of 112 kilograms per hectare and contained, again, by weight of seed, 75% cereal rye and 25% hairy vetch. These cover crops, they were chemically terminated approximately 2 weeks prior to cash crop planting, which on the corn side of the experiment came out to kind of that last week in February, which is when we terminated. And then on the sorghum side of the experiment, we terminated closer to that second week in March, right around when we're planting corn. Cover crop biomass was harvested from 1 square meter within each strip plot. And I should define the size of those strip plots. We have pretty big strip plots. They're 3 meters wide and they are 45 meters in length. And I took 1 square meter from smack in the middle of it to try and get kind of a representative sample from each of the subplots. That biomass was then dried and weighed in order to determine kind of average biomass production by each of the cover crops. And then a representative sample of said dried biomass was placed into 5 litter bags with 3 replicates. There were 15 bags per cover crop, which were then removed on average every about 27 days in order to measure decomposition in the field. And those litter bags were created by me using 1,000 mesh nylon fabric ordered from industrial netting up there in Minneapolis, Minnesota. After imposition of the herbicide treatments, weed biomass was collected, dried, and weighed at 3 time points 30 days apart to measure kind of just weed biomass in the field from 3, 0.111 square meter sections. So we had 1/3 of a square meter from each subplot. And at the end of the season, when grain was mature, kind of second week of August, grain was harvested using a John Deere 3300 block combine. For statistical analysis, data were subjected to analysis of variance using Proclimix and SAS 9.4. We treated year as a random variable, but the data were subjected to Levine's test for quality of variance before combining years within the analysis. And if it didn't pass that test, we treated the years independently and evaluated them, which is what happened when for cover crop biomass, as well as when we evaluated cash crop stand, which I will be showing in this next slide as we enter the results section of my presentation. So this is cover crop biomass preceding corn. And these cover crops were grown on average for 130 days, kind of from mid-October to, like I said, late February. And it failed Levine's test, so I broke the cover crop biomass production apart by year. But in each year, we saw that spring wheat, which is these blue bars here, produced significantly more biomass than the other cover crops. And it usually entered the reproductive stage of development by the time we harvested. Conversely, winter wheat, which is these red bars right next to the spring wheat, tended to produce significantly less biomass than the other cover crops. As you probably saw in the image where I showed my cover crops, the winter wheat didn't really do much in 2020. It just kind of hung out. It all germinated, but it didn't really grow much. And then the 5 species mix, while not performing the best, at least in the first and third year of the study, did produce the most consistent biomass across all 3 years. So moving into the cover crop biomass production preceding sorghum. So these cover crops were grown on average for 147 days prior to termination. So they had an extra 2.5 weeks to grow compared to the corn. And we see that with that time, the 5 species mix and then the rye vetch, they tended to catch up a little bit. Because during that time frame I'm talking about, it's a little bit warmer, a little bit wetter, and the cover crops are just a better environment for them to grow. We saw that, in kind of the third year, as you guys might expect, or you guys might remember if you haven't blocked it out, a little bit cold there early February, if you guys recall. And our spring wheat did not tolerate that cold. The other 3 cover crops did, but the spring wheat was pretty much killed to the ground. So this biomass that I was collecting was all dead and kind of rotting. But the other 3 cover crops did just fine. leaf burn a little bit. The vetch in some of the plots was kind of fried, but it came back. And as such, it had, significantly more biomass. When looking at the average cover crop biomass, comparing the crops, with that extra 17 days to 2.5 weeks of growth, we see that winter wheat tended to produce about 33% more biomass. 5-species mix 36% more biomass, and the rye vetch mix produced 32% more biomass on average. Whereas the spring wheat, it had pretty much headed out, entered the reproductive stages of its development, and didn't grow much more. So going into corn plant stand for the corn, we failed to see a significant effect based upon the cover crops year to year. Again, this failed Levine's test, so I'm evaluating the years independently from each other. On the first year of the study, we did see that corn following spring wheat did have significantly lower stand than the other cover crops and than the fallow treatment. However, this pattern did not repeat itself in the second year. And in the third year, we did see significantly lower stand again. But I mean, it's still 94% stand, and even though it's significantly lower, it's not by much. In the third year of the study as well, we did see that corn following our 5-species mix did have significantly lower stand as well. And it was kind of the same deal with sorghum. The first year of the study, I got a little excited looking at this because I'm like, okay, obviously there is, with all the cover crops, there seems to be a negative effect on stand with all sorghum plots following all cover crops having significantly lower stand. However, this pattern did not repeat itself in the second or third year of the study. So tough luck for me, I guess. So now going on to cover crop decay. So this is in the corn side of the experiment. So these cover crops were grown for 130 days. They're a little less mature than on the sorghum side. However, we saw that the cover crop or spring wheat tended to decay at a significantly lower rate. And this unit here on the y-axis is the percent of dry matter remaining. So, I know how much I initially put in the bag, and then I removed the bags at these time points here on the x-axis, and I evaluated the percent remaining. So that way it would be easier to compare between the years. And we saw, this asterisk denotes significant differences. And at this time point and at the last two time points, spring wheat had significantly higher biomass remaining within the litter bags compared to the other cover crops, which did not differ from each other. So that's just kind of a fancy way of saying spring wheat decayed at a slower rate than the other cover crops on the corn side of the experiment. And we saw the same thing on the sorghum side of the experiment. So a little bit slower, but same thing. Moving into percent weed control. So this is by percent, again, compared to our weedy checks, the micro plots. We saw that, as one would expect, a post-emergent herbicide does lead to significantly better weed control when compared to a pre-emergent only. And we saw with the early post that by the later part of the season, so 120 days after planting, a lot of that control had kind of fallen off, which we did not see with the later posts. And we saw kind of the same thing in sorghum, where again, these guys they had better control compared to the pre-emergent only. And we saw with both the early post and the mid post kind of a bit of fall off there. When evaluating, again, the cover crops, and this is pooled for the cover crops here, it's pooled across all of those herbicide treatments I just had. We did not see any significant differences between the cover crops and percent control. It looks like it's a little bit lower here for spring wheat, but again, those differences were not significant for any of these time points. And again, same with corn. There was no significant effect one way or the other on percent weed control based on cover crop alone. And there was no significant interaction between the herbicide treatments and the cover crops as well, I should mention. So finally, moving into our grain yields. as we did not see a significant effect, positive or negative, from our cover crops on our corn grain yield. And we saw the same thing in sorghum. We saw no, it's a little bit lower, but again, those differences were not significant. And we failed to see any effect from our cover crops. So in conclusion, our spring wheat consistently produced the most biomass within the shorter growing season for corn. So if you're looking to adopt a cover crop, maybe in a corn system, spring wheat might serve you a little bit better if you want to have that biomass. But the other cover crops caught up with kind of the additional time that would be typical in a sorghum system, that extra 2.5 weeks. Spring wheat also decayed at a slower rate than the other cover crops, possibly because the crop itself is more mature. We will be getting the carbon nitrogen ratios on that in the future. Got to run those yet. And cover crops did not have a consistent negative effect on crop stand in both corn and in grain sorghum, as well as cover crops did not have a negative or positive, for that matter, effect on cash crop yield. So acknowledgements. I'd like to thank the members of my committee for all their assistance, Dr. Schnell, Dr. Proven, Dr. Rajan, Dr. Welch, and Dr. McGinty. I'd also like to thank the members of Dr. Rajan's lab for some of their advice and tips and on sourcing the material as well as making of the litter bags, especially Pramod and Diana. And with that, I would welcome any questions that you have. Thank you for your attention and your time. Yes.
Thank you for the presentation. From year to year, we are seeing a dramatic change for any trade of the event. So pretty much what I understood is like your results was affected because of change the environment. So my question is that have you ever included any environmental effects as a like a core in your model while you were running this science?
So the question was if I had ever included some of the environmental conditions as a covariate when running it in SAS. I have not yet. I'm in the process of getting all of, because there's the weather station on the farm where you can get all of the precipitation data. I've got 2 of the years kind of downloaded that input, and I'm still working on getting the data from 2021 as well as the temperature, because that is interesting because you're right, environmental conditions do matter. For example, in fall of 2018, we had the wettest October on record. And in my 5 species mix, the peas kind of drowned. They didn't do much of anything. However, in the second year of the study, the peas really loved how dry it was and took off, which is one of the benefits probably of having a multi-species mix with different environments. The different species in that mixture will perform better or worse. But no, I haven't put it into my stats yet to run it, but I do plan to. Thank you. Yes.
Some science guys, I know not much all, but could you put in like a sentence or two? What's the most significance of your findings or your work that on your field routine?
That there isn't a negative impact. Oh, sorry. The question is, what would kind of be the biggest takeaway of kind of this presentation, this research that people interested in cover crop research would be interested in? And it'd be that there isn't a negative impact on yield. I mean, I showed kind of those slides with the amount of biomass production, and that's just sitting on the surface. I mean, and that did not have a consistent negative impact on crop stand. So our cash crops, they're able to go through that mulch without a kind of a negative effect. And nor did they have a negative effect on cash crop yield as well. So the lack of anything is not necessarily bad. It means it doesn't hurt you, which is good because there are benefits for soil health and other things as well.
Jack, do you have plans to look at the economics of cover crops?
I do. So I know I have seed costs all down. I know how much money you get through equip and all that, but some of the estimated labor costs and costs of fuel and stuff, I I do not have, and I need to work on that as well. Donovan, yes.
So typically, before you would plant, you would spray some type of pre-emergent herbicide. Anyway, when you use a cover crop versus on a fallow ground, is there any need for increased herbicide application before planting or after?
So the question was there a need for increased pre-emergent application of herbicide on the fallow?
Oh, with cover crops, do you need to use more than you typically would without cover crops?
Well, because we hit it with a burn down so that is an additional cost that goes into it. And we did have to change that. The first year we used glyphosate and sharpen, and we found that sharpen it didn't knock that vetch back all the way. The vetch came back and became kind of a weed until it kind of burned off and the temperatures got hot. So in the second and third year of the study, we actually had to switch the way we terminated. We had to use dicamba instead. We used rifle and glyphosate. So that is a management concern, is what you're using to terminate the cover crops, the timing of which, and it's an economic concern as well. But if you're going to be hitting, your field with a burn down anyway, you're doing it anyway, you may as well. But yeah.
Okay. I would like you to clarify this soil benefit. If the farmer is planting a cover crop, he is incurring cost to that. And if there is no effect on the yield of the next crop, how does he quantify the benefit from soil benefit? Soil benefit that you are saying. So what is the ultimate gain to the farmers for this investment? And I'm surprised that there is no legume as a cover crop, because that at least will fix some nitrogen. Thank you.
Right. No, I was surprised by that as well. But the question was, I think you were all able to hear it, but what additional benefit to the farmer would we get if there wasn't a benefit in yield? And while I didn't measure that, there is, kind of a growing body of evidence, not necessarily growing, and it is contradictory sometimes depending on the system you're in. And it's not particularly my focus, but some of that soil health, it's, there is evidence in some cases, again, I got to quantify that, that there are improvements to, say, water infiltration rates. So say in like the Midwest on like a no-till system, you'd have less water pooling and then less flooding as well in the spring. And compaction as well is also a concern, particularly in no-till systems that cover crops can assist with. But again, that wasn't the focus of my research, but that's part of the balancing act, look, and it's not going to work for everybody. Cover crops might not be the best for every agricultural system. But if we can quantify the benefits as well as be aware and honest about the costs, we can give good advice to agricultural producers that are looking to adopt these. I think time for one last question. Yeah. Yes, I'm looking to use Dr. Rajan's Elementar as well. I'm in the queue. I'm in the system to use it, but I haven't run it yet. Oh, is there one more question on the? So did it help? So it didn't hurt cash crop yield, but cover crops cost money. So did it help at all? That's kind of a similar question. It's one of those like quantifiables is soil health and ecosystem services. And I didn't really evaluate those in my research yet. We will be looking at soil carbon and the like later. But yeah, with that, I believe we're out of time for the next presentation.
Thank you.
So, I guess I'll hand that to you.